Hello everyone, I am Dr. Gerolina Fernandez, Assistant Professor, Department of Science at the Bhopal School of Social Sciences. Dear students, in the previous few lectures, we have discussed about the definition of integration and some standard formulas. So now, in this module, we are going to discuss about the concept integration by parts, which is one of the most important topic of calculus. So integration by part is a special method for integrating the product of functions. For example, if we have to integrate x cos x, so in this particular example, we will use the method integration by parts. Similarly, integral of x, natural log of x dx. If we have to calculate this function, the integration of this function, we will have to use integration by parts, in which the integrand is the product of two functions. Here you can clearly see that in the integrand part, you are having x and cos x. X is an algebraic function and cos x is a trigonometric function. So the integrand will be the product of two functions. So in this case, we will use integration by parts. So this method is based on the product rule for differentiation, in which we also have two functions. This method is used when normal integration and substitution do not work. So now, moving on to the formula of integration by parts. For this, we want two functions, u and v are two functions of x. Then the integral of the product of two functions, here we have taken u into v, is equal to the product of the first function multiplied by the integral of the second function minus integral of differential coefficient of the first function multiplied by the integral of the second function. So if I say u and v are two functions of x, I consider u as the first function and v as the second function. So if I have to calculate the integral of the product of two functions, then that is given by the formula. First function remains as it is. We do the integration of the second minus whole integration differential coefficient of the first function. Here the first function is u and the integration of the second function. So this is the integration by parts. That is, we take the integral of product of two functions. Now the key thing in this integration by parts is we choose u and v correctly. So the acronym ILATE is good for picking u. That means I am talking about the first function. So ILATE stands for, I stands for inverse trigonometric function. For example, sine inverse x, cos inverse x. These are inverse trigonometric functions. L stands for logarithmic functions. Here we can take common log and natural log. Then A stands for algebraic function. For example, x, x square. T stands for trigonometric functions. For example, sin x and cos x. E stands for algebraic function. For example, e raised to the power x, e raised to the power sin x. So there is a note for selecting u and v. So the closer the function is to the top, the more likely it should be used as the first function. That means we follow the pattern from top to bottom. Now let's understand this concept with the help of few examples. So the first question is, you have to evaluate integral x e raised to the power x dx. So here we have product of two functions. That means we will have to use the ILATE rule. Now here I stands for inverse function, inverse trigonometric. L stands for logarithmic functions. A stands for algebraic function. T stands for trigonometric function. And E stands for exponential function. So you'll have to move from left to right and select according to the order. So here x is an algebraic function, as we have already discussed it previously, and e raised to the power x is an exponential function. So moving from left to right, this is algebraic function and exponential function. That means this x will be our first function and e raised to the power x will be our second function. So basically you will have to first decide with the help of this isolate rule that from the product of these two functions, which function will be the first function and which one will be the second function. So I'll repeat it once again. In this particular product of two functions, since moving from left to right, algebraic functions comes first and exponential function comes second. So here this x will be treated as the first function and the exponential function will be treated as the second function. So we'll start with the solution. We'll assume this whole integral as I. So let I is equal to integral x e raised to the power x dx. This is our integral. And first function is x and the second function is y, e raised to the power x. So using the formula, product of two functions u and v, the first function remains as it is, integration of second minus whole integration, differentiation of the first function and integration of the second function. Here it will be x dx. So comparing, here u is x and v is e raised to the power x. So you just have to substitute the value of u and v in this formula. So integration of x e raised to the power x dx, by taking x as the first function, e raised to the power x as the second function. So first function remains as it is, integration of the second minus whole integration, differentiation of the first function. So here first function is x multiplied by integration of the second function. So here the second function is e raised to the power x. So as we know that integration of e raised to the power x, is x. So that will become x e raised to the power x minus whole integration of within square bracket differentiation of first. So we know that differentiation of x with respect to x is 1 multiplied by integration of second. So integration of e raised to the power x is e raised to the power x. So finally we can write x into e raised to the power x minus e raised to the power x into 1 is e raised to the power x, and integration of e raised to the power x will be same as, that is e raised to the power x, plus we add the constant of integration. Why? Because this is an indefinite integral, and indefinite integrals we have already discussed about this topic. So for that we add the constant of integration. So therefore the integral x e raised to the power x dx is equal to x e raised to the power x minus e raised to the power x plus c. So this is the solution. Now we'll start with the second question. So second question is, you have to evaluate integral x cos x dx. Here also we have product of two functions, so therefore we cannot apply the integration for elementary functions. So again we'll use the isolate rule. Now according to isolate rule, we move from left side to right side. So out of these two functions, whichever functions comes first, moving from left to right, that will be treated as the first function and the other one will be treated as the second function. So here also we have x is an algebraic function and cos x is a trigonometric function. So therefore, moving from left to right, algebraic functions comes first and trigonometric functions comes second. So therefore, here u is x and v is cos x. u and v are, u is considered as the first function, v is considered as the second function. So writing the formula of integration by parts, u is the first function multiplied by v, v is the second function. So that is equal to first function remains as it is multiplied by integration of the second minus whole integration differentiation of first. So differentiation of first multiplied by integration of second into dx. So we have already discussed u is x and v is cos x. So we will substitute the value of u and v in this formula. So here we are using integration by parts. Why we are using integration by parts? Because within the integral, the integrand is product of two functions. So substituting the value, therefore x cos x dx is equal to first function as it is, integration of cos x dx minus whole integration differentiation of first. Here first is x and second is cos x minus whole integration differentiation of first is x into integration of second, that is cos x dx. So as we all know, integration of cos x dx, this is sin x, and integration of and differentiation of x will be 1. So these are the two formula we will use. So first function remains as it is, integration of cos x is sin x minus whole integration within square bracket differentiation of first. So differentiation of x will be 1 into integration of second, that is sin x dx. So as we all know, integration of sin x also, integration of sin x dx is minus cos x. So we will substitute the value of integration sin x over here. So therefore we are getting integration of x cos x dx is equal to, so that is equal to x sin x minus, that is equal to x sin x minus integration of sin x dx. So we all know that integration of sin x is cos x, and since we are dealing with indefinite integrals, therefore we will have to add plus c, that is c is the constant of integration. So now the third question in this series is you have to evaluate integration of a natural log x dx, integral log x dx. So we will assume this integral as I. So let I is equal to integral log x, and here we are dealing with common log x dx. Since we don't have any formula for log x, therefore we will multiply this function log x with 1 and select first and second function with the help of isolate rule. So moving from top to bottom, log comes first and 1 can be treated as x raised to the power 0, that is an algebraic function. So that will be treated as the second function. So here we can say that according to the formula, u is log x, that is the first function is log x, and the second function is 1. Why we have taken the second function as 1? Because x raised to the power 0 can be also written as 1. So 1 can be replaced by x raised to the power 0. Similarly, x raised to the power 0 can also be replaced with 1. And moving from top to bottom, either you can move it from left to right or you can move it from top to bottom. So if I move it from top to bottom also, the preference will not change. First function we are getting logarithmic function in the product of these two, and the second one is algebraic function. So moving from top to bottom, the order remains same. Logarithmic function comes first, so that will be treated as the first function, and algebraic function is appearing to be the second part, so we will treat it as the second function. So substituting the value in the formula of integration by parts. So therefore using integration by parts, we'll write the formula first and then we'll substitute the value of u and v. So integration u dot v dx, where u is the first function and v is the second function. So that is equal to, first function remains as it is, integration of the second function, here the second function is v dx, minus whole integration, differentiation of first multiplied by integration of second dx. So as we have already discussed that the first function is log x and the second function is x, so we will substitute the value. So the first function is log x and integration of 1 dx minus whole integration, differentiation of first. So first is log x multiplied by integration of second. So we already know that integration of 1 is x and differentiation of log x is 1 by x. Since integration of 1 dx is x and differentiation of log x is 1 by x, so we will substitute the value over here and in these parts we will substitute the value. So finally integration log x dx is equal to, first function remains as it is, integration of 1 with respect to x will give you x, minus whole integration, differentiation of log x will be 1 by x, multiplied by integration of 1, that is x multiplied by dx. So here I can write it as x log x minus this x gets cancelled and we have integration of 1 dx. Now integration of 1 is again x. So this is the value of the integral and we will have to add constant of integration. Why? Because we are dealing with indefinite integrals. So that's all in this module. Thank you for watching and have a happy learning.